So yeah, I'm Michelle. I'm a first-year student in econ and ecology, and I'm going to talk today about some work I did as part of a rotation with Courtney Murdoch, who has a joint appointment in infectious diseases and ecology. So as a disease ecologist, I study disease in the context of its environment. And for vector-borne disease, this kind of has three components: the vector, such as a mosquito, the pathogen itself, and the focal host. And what this means is if there's a change in the environment, say climate change or land use change, this can then affect all three of these components and affect the disease dynamics. And what I'm specifically interested in is urbanization and mosquito-borne disease. So in general, it's expected that urbanization is going to lead to increases in mosquito-borne disease. There's a lot of different hypotheses why, one of which is the kind of increase in impervious surfaces leads to more standing water, which provides more mosquito habitat, or the urban heat island effect, whose hotter temperatures can lead to faster development rates of mosquito larvae and higher population growth rates. So I was working with Courtney, and we work in the chikungunya system. Chikungunya is a virus that causes fever and joint pain, and it's in America and is just started to spread, or it's in the Americas and it's just started to spread to the US with its first locally transmitted case last year. And it's spread by mosquitoes of the Aedes genus, and we were specifically studying Aedes albopictus, which is also a vector of diseases like dengue and a potential vector of Zika, if any of you have been following the news. So it's really important, basically, is what I'm trying to say. So we were studying this across an urban gradient, and we did this in Athens by following mosquito populations across 3 land use types. We also measured microclimate at each land use type, so temperature, relative humidity. And we did all of this with the goal of getting population growth curves for mosquito populations in urban, suburban, and rural areas. So to do this, we chose 3 rural, 3 suburban, and 3 urban sites. And at each site, we placed 6 replicates of populations of 30 albopictus larvae. Then we visited these little pots of larvae every day, collecting mosquitoes as they emerged, and that allowed us to get these emergence curves of how many mosquitoes are emerging each day. At the same time, we had temperature loggers, both in the larval environment, so in the water, and in the adult environment, which is just right next to the pots. So this is kind of an overwhelming plot, but it's just a plot of temperature over dates. And this is the mean temperature, well, minimum, mean, and max temperature for the adult climate. And the 2 main things I really want you to grasp from this are that the urban areas in red, right there, were consistently hotter than the rural and suburban areas. And if you look later in the season, kind of in early fall, you see these extreme heat events, which is where urban areas just had these really high max temperatures. And both of these are just kind of more supporting evidence for this urban heat island effect. So I'm going to kind of skip the nitty-gritty of how we get these population growth curves, but I'm happy to talk about it outside of this 5-minute time window. But basically what we found was that the per capita growth rate was actually lower in urban environments, which isn't really what you would expect reading the literature and all of this concern about urbanization and mosquito-borne disease. But it's important to remember that disease is more than just mosquitoes. And so a lot of these studies, when they're looking at it, are considering this kind of complex web of things. So if we go back to the original little, simple triangle I showed you, disease depends on the mosquito vector, the pathogen itself, and the host, in this case, humans. And so part of my dissertation research is I want to use this kind of icon interdisciplinary method of approaching a complex issue to draw on methods from different disciplines, different type of epistemologies, to get a better understanding of this kind of complex question that doesn't really fit easily into one discipline. It really spans a lot. I don't really have that many. I have ideas, but I'm not quite sure how I'm going to do this. So if anyone wants to talk to me about this, please come up to me at the reception, because I'm definitely all ears. So with that, I'd like to thank my collaborators, the Murdoch Lab, my funding sources, and you all for coming to the very last talk So hopefully now pizza and beer, right?